Welcome to The Explainer. You use it every single day, but have you ever stopped to think about how the internet actually works? Today, we're going to trace that amazing journey from your keyboard out across the entire world and back again, all in the blink of an eye. It really does feel like magic, doesn't it? You type a few words, hit enter, and bam, a whole world just appears on your screen. But here's the thing, it's not magic. It's an unbelievably fast and complex journey, and we're going to follow it every single step of the way. All right, so here's our game plan. We'll start with that digital journey you take every day. Then we'll talk about your vehicle, the web browser. We'll look at the address on the map and the internet's secret phone book. We'll even figure out what's actually on the internet. And finally, we'll see how it all comes together, from your click to the content you see. Every journey has to start somewhere. For us, it's that simple act of deciding where you want to go online. That one decision is your entry point into this massive, interconnected web of countless smaller networks, all speaking to each other across the entire globe. But to get around on these vast digital highways, you're going to need a vehicle. And that vehicle, well, that's your web browser. Just think of it like a car or a bus, maybe a train. It's the piece of software that reads the map, understands what you're asking for, and actually takes you to your digital destination. Without it, you'd basically be stuck at the station, not going anywhere. Now, what's really interesting here is that while all these browsers, Chrome, Firefox, Safari, Edge, all look a bit different, they're all doing the same fundamental job. It doesn't matter which one you prefer. Each one is built to read the same map and follow the same rules of the road to get you where you want to go. And just like on a real map, every single destination needs an address. On the internet, we call that a URL, which stands for Uniform Resource Locator. Now, I know it can look like a jumble of letters and symbols, but just like a street address, every single part has a very specific meaning. For example, let's take a look at a full address, like this one. It might seem a little complicated, but it's really just a precise set of instructions for your browser. So let's break it down piece by piece. So, the first part, HTTP, stands for Hypertext Transfer Protocol. The easiest way to think of a protocol is as the language the computers agree to speak. This part tells the browser how it should ask for information from the server. It's setting the rules for the whole conversation. Next up, we've got the domain name, in this case, igno.ac.in. This is the part we all recognize, right? It's the memorable, easy-to-read name for the website. It's the brand, the main location. But here's the twist. This name is for us humans. Computers, they don't actually use it. And finally, we have the path. So if the domain name is the address of a giant office building, this last part tells you the specific floor, the room number, and even the exact file you're looking for inside a filing cabinet. In this case, it's a PDF file named Contact Us 2019. So wait a minute. If computers don't use those friendly domain names that we type in, how in the world do they find the right server out of the millions that are online? Well, the answer is they use numbers. Every single device connected to the internet has a unique numerical label called an IP address, and there are billions of them. So while we humans remember a name, the computer needs to know the server's specific numerical address to find it. And that's where the domain name system, or DNS, comes in. This part is seriously clever. You can think of it as the internet's giant automated phone book. When you type in a name, your computer asks the DNS server, hey, what's the number for this? And the DNS server finds the matching IP address and points your browser to the exact right place. Okay, so your browser has the IP address. It's ready to send its request for the web page. But that request doesn't travel as one big chunk. Nope, it gets broken down into little pieces to make the journey much more efficient. This whole process is governed by a set of rules called TCP/IP. And here's a great way to think about it. Instead of sending a whole book in one giant box, TCP/IP tears out every single page, puts each one in a separate addressed envelope, and mails them off. Those pages might take different routes, but once they arrive, the TCP part acts like a librarian, making sure every single page is there and putting them all back together in the correct order. Isn't that amazing? Now, here's a super common mix-up. It's really easy to think that the internet and the web are the same thing, but they're not. This is a crucial distinction. The internet is the physical network, all the cables, the routers, the servers. You can think of it as the roads. The World Wide Web is just one of the things you can do on those roads. Yeah, the World Wide Web is that whole universe of websites and documents and videos all linked together. When you say you're browsing the web, you're using the web, and it's probably the most popular service that runs on top of the internet's infrastructure. But it is definitely not the only one. Another essential service you use all the time is email. It also runs on the internet's roads, but it uses its own set of traffic rules. So sending an email uses a protocol called SMTP. But when it comes to receiving your mail, you actually have a very important choice to make between two different protocols. And the difference is all about where your email lives. With IMAP, your mail stays on the server, which means it's always synced up across all your devices, your phone, your laptop, your tablet. With POP, on the other hand, it's more like going to a physical post office. The mail gets downloaded to one computer and then it's gone from the server. POP is fine if you only have a single desktop, but for our modern multi-device world, IMAP is pretty much essential. So now let's put all of these pieces together. Let's recap that entire amazing journey, from the moment your finger hits enter, all the way to the content appearing right there on your screen. So let's run through it one more time. You type a URL into your browser. DNS translates that name into a number, an IP address. Your request gets broken into little packets and sent through the network using TCP/IP. The server gets those packets and sends the web page back to you, also in packets. And finally, your browser catches everything, puts it all back together, and displays the page. And the most incredible part? All of this happens in less time than it takes to blink. It's really an invisible system, built on simple rules that allow for this incredible complexity. It already connects billions of us, but just think about what happens when it starts connecting trillions of devices tomorrow in our smart homes, smart cities, and the whole Internet of Things. Understanding how it works today is really the first step to imagining and maybe even building its future.